So my friends, allow me to tell you about my sad and tragic tale, about how I basically took everything through what you just saw, and the minute that I tried to add additional explosions, I ran into all kinds of issues. Go figure, right? This is probably to be expected with a huge project like this at some point. Now, I'm going to talk about what didn't go well. But before I do that, I want to mention something that when you decide to add additional explosions into the mix. So in this case, we have one explosion happen, and then we have 3 or 4 more explosions happen afterwards. When you do that, you've also multiplied the number of areas that can go wrong. All it takes is for one little thing to be off, one little time shift to be not quite what it needs to be, one checkbox that you forgot to tick, one cache file that didn't have enough frames, and the entire sequence can potentially be ruined. And because we're working in a way where we are, caching many things out to get the final simulation, there's a lot of dependencies that are required for each simulation. And all it takes is for one dependency to be off somehow, and an entire sequence may be ruined. Now, let me show you guys what I came up with for the Karma render and the comp that I just showed you how to make. All in all, it's looking pretty cool. We have 1 explosion, and then we have 3 show up. However, there were some things that did not go very well. For one, once we have these explosions going, motion blur is not working. I accidentally forgot to cache out velocity. And the reason why that happened was because I was running out of disk space. I wanted to check a few things on the simulation, and I forgot to turn the velocity back on. So, whoops, my bad, but I couldn't figure that out until I was already 163 frames in. Also, motion blur got messed up on the debris. So the debris is all fine here, but the minute that the other explosions hit, the motion blur got messed up because of the fact that when I went to calculate velocity, I forgot to check on the name attributes being the seed for that velocity. So again, a very little basic checkbox, but all it takes is one to mess up a whole render. Now, the reason why this is a big deal, and it looks like we're popping cache files here too. So a lot of things did not go well. Also, these frames towards the end got very grainy because I tried reducing the samples. Now, the reason why I tried reducing the samples here was because of the fact that these renders were taking 15 minutes apiece for just the pyro elements, not even including the ground. I would say 15 minutes is what you see right here with the grain. And so by the time I reached this part of the render, I was already about 3 days straight worth of rendering. And then all of these issues decided to show up. And there were many renders before this where I caught an issue and I restarted it. So look, the reason why I'm telling you all this is just to be realistic. If this is something that you're trying to do in a studio, you really, really have to be careful. And just to add to that, everything that I've been showing you thus far in this pyro tutorial, if I haven't emphasized this enough, is educational. It's meant to give you the ingredients to make a better workflow. You can use tops, you can use all kinds of various tricks and techniques to dummy-proof a system that works for you. But before you show up at a studio, I do think it's a really wise idea to come up with your own system that you've tested out many times, that you've kind of gone through the ropes with, that you feel comfortable with, that is more simple than what I'm doing here. I tried to show you every single trick in the book. That's probably not going to be realistic or necessary for most situations, honestly. And if you're trying to render this with just your one machine, you have to be really great at time management, and again, just double checking everything really thoroughly. Moving on though, what are we going to do to finish off this course? Well, I'm going to quickly show you the setup that I used to get all those multiple explosions brought in. I know you're just dying of curiosity how I was actually doing that. but I'm going to show you that. And then once I get done showing you that, we're going to finish off by rendering all the final frames with Redshift as one whole thing. Again, I'm a big believer of trying to render everything in the same place. Having that backplate there did work with the shadow pass and all that, but it still just looks better if you can make everything happen in one render engine. And I want to make this teaser for the course look as beautiful as possible. So that's the route I'll be going. Also, like I've said before, Redshift is currently redoing the way that it handles volumes in many different ways. So that will probably have to be re-rendered yet again in the future. But anyway, that's what you can expect coming up here soon. So without further ado, let's jump into Houdini and I'll quickly give you a tour of how I managed multiple explosions in this scene. There are a variety of ways you can try to handle the situation. The main idea, though, is that we want to simulate everything at frame 30. We have all kinds of different keyframes happening. We've basically timed it so that a missile up here will start up here, shoot down, and land somewhere at frame 30. So we don't want to mess that up. So what that means is that every single explosion will happen at frame 30, just at different locations. So that's the first thing to understand. Now, as we go to cache this out, I'm using this switcher. And this is just a null. And I've gone up here to this little cogwheel, said edit parameter interface, and added in some float parameters. Float and integer parameters, so that basically we have something here to control the different cache files and what sort of version of a cache that we're saving out. This stuff can absolutely be achieved by using tops. However, I just wanted to go with something that was as straightforward as possible in this particular situation. So on that switcher, let's say that we're at a value of 0 to start. That hooks up with this missile sim build right here. I've isolated all these various points. I have a time shift here that basically makes it so that they all hit on frame 30. We isolate the points, and this switch right here is going to listen to, again, what I was saying here in this switcher value. So if we have an index of 0, it's only going to listen to, let's say, that first point along here. And that goes through the switch, and that dictates everything we just did with the large plume build. So I went through manually with every single cache file that we have here, and anywhere that I cached something out, I then went ahead and just rewrote over whatever was originally there. As an example, this density value does not need to be versioned up. I don't want it taking extra disk space every single time I do that, so I would just overwrite whatever was there. Now, certain things do need to have a versioned cache file to them, though. Obviously, if we're caching out the final pyro frames down here, or the final pyro plume cache files, I should say, we want different versions. So with Houdini 19, we can specify this version. This file cache allows you to plug that in, and it makes a separate folder, which is nice. That can link up with the switcher, and you need to add 1 to that so that we start at version 1 and we go to version 2, 3, 4, etc. So that's what gives me the different cache files versioned up. Again, you only want to do that with the stuff that's going to be seen in the render. So that happens for our main plume, it happens for the spikes, for the debris, for the shockwave. And again, if you wanted to automate this, you could do that with tops. You could also go and try to do something fancy in the out context. Look at all these different ROP operations that I've made right here. It's kind of crazy. But, and by the way, specifically, you guys should already know this, but you could just do a geometry ROP to trigger those cache files if you'd like. But anyway, you could go that route. I decided to go through everything manually just to double check things as they were being cached out. And basically the idea is that everything happens at 30, right? And then we can offset that to whatever frame we want afterwards. So in this case, let's say we have the second plume coming through here, right? And the minute that the second plume happens on frame 30, we then can offset that to whatever value we'd like. So that's what this retime here is for. You'll notice that the retime is happening between 1 and 330 originally. That's the whole range. And then I'm just scooting everything over by something that I specify on the switcher. So when we go back up here on our mighty switcher, we have all of these frames like so. The way that I was thinking about this is that if I want something to land on, let's say frame 157, I do that minus 30 so that it will happen 30 frames after the new sequence has begun. So again, that info goes down here to the retime. And once we hit something again around 150, we start seeing things happen. So that's the main idea. This again happens for the large plume. It happens for the spikes. It happens for the debris, all the various things. Now, because we're adding 5 times the amount of data to our scene, your viewport is going to get very, very slow. So do keep that in mind and try to not spend too much time letting your viewport load as you are setting this up. But anyway, that's pretty much all you do. For the actual missile, the last thing to put together here is to bring in everything that we did with the original missile sim. We reapply the offset to all the various points. And then that gets brought in for what we already have in the missile model network. So hopefully that makes sense. Again, there's better ways to do this, I'm sure, but that is what I did to try to add in multiple explosions. In the next video, let's move on by rendering out the final image.